Okay, so welcome back. We'll continue our discussion that we were having in terms of doing the representative sample. So when we are trying to collect the representative sample from electronic waste, if you remember, like these are some of the pictures, some of the slides we were looking at towards the end of the last video. So how to collect the representative sample and how to do the size reduction. This was a discussion we were having. So one option I said was you can cut it by hand. So if you have a cheap labor available, you can cut it by hand, where you can get the work of different you can involve different people, you cut it by hand, but it's a very time consuming process, and it's a hard process as well, like you can using those pliers and cutting through those and then, but again in terms of this is for the size reduction, but in terms of the representative sample, what I said was you look at the composition of the electronic waste or that particular electronic waste that you have. Then you take, say, out of 100 gram that you have to do TCLP on, because TCLP test requires 100 grams and 2 liters of solution. So out of that 100 grams that you need to have for TCLP, you take it in proportion of the different weights of the individual component that you have. Say for example, as you can see in the picture here, for any waste that you pick it up from this pile, it has plastics, it has glass, it has metals, it has printed wire board. So what, say if that composition is for the simplicity's sake, let they are all equal, 25%, 25%, 25%, 25%, say there is only 4 components. So out of 100 grams, we will take 25 grams of plastics, 25 grams of metals, 25 grams of printed wire board, 25 grams of other material. So this is how you will come up with your 100 grams. It has to be in proportion to the different components which is present in the electronic waste. Say if you take the 100 grams just for the plastic, that's not representing the whole e-waste. If you take just the printed wire board, that is also not representing the total e-waste. So you have to take the sample in proportion of the individual components in that e-waste that is present there. So once you decide what should be the composition of your 100 grams, of course you need to size reduce. So you need to size reduce the different components, and you can do it either by hand. This is one way of doing it. Of course it's time consuming, or you require some labor requirement, but it can be done in this way if you don't have the mechanical devices with you. More common these days, and more thing you see, the people try to use some sort of grinder, and this kind of grinders are available in the market where you can take and put it in the grinder. So what happens here is you put your e-waste in here, which is trying to grind those different components, and then you have kind of like a size reduced electronics, and from here you take it e-waste, and then from here you size reduce it further by hand or some other purposes as needed for TCLP requirement. Because what is the TCLP toxicity characteristic leaching procedure? The test requirement is the size has to be less than a centimeter. So less than 1 centimeter it should be there. So that's why it has to pass through the sieve, which has a hole of 1 centimeter. So that's why we need to do the size reduction. If you remember what I said about the size reduction from the very beginning of the maybe second or third week of the class, size reduction is done to increase the surface area. More the surface area, better the reaction. So size reduction is to make it more conservative, so that you have a bigger surface area, more surface area, the reaction will be faster, and that way you can able to more and more things will move from the solid phase to the liquid phase, and that's what we want. We want to see the worst case leaching scenario. So that's why we want to create. We are creating a condition in TCLP test so that there is a worst case leaching scenario of this heavy metals and organics from the solid phase to the liquid phase, so that to see whether it will have a potential to contaminate the groundwater in the event that this gets disposed in a landfill, municipal solid waste landfill. So if it goes to the leachate, from leachate it will go to the, if it passes through the liner system, whether it will contaminate our groundwater or not. So that's the whole concept behind this TCLP test, which we have already discussed earlier in when we were talking about the municipal solid waste. But this is how to get the sample. This is how you can grind it and size reduce it further if needed, and then whatever you get the sample, and you can do the TCLP test on those size reduced sample. Excuse me. Another option, which is actually that's what many times if you go and give a talk like this, where you have a lot of electronics producers present there, and also e-waste handlers are present there, they will say, why you are even size reducing it? Because when you are size reducing it, you are making that's not the realistic, because what will happen, say if I put a electronic waste in the landfill, I'm not going to cut it through those scissors that you showed me, or I'm not going to pass it through a grinder, because why should I do it? It's costly exercise to pass it through the grinder or to do the cutting through, and that's not needed. I will just take the e-waste and just dump it into the landfill. But in that case, nothing is going to happen. Maybe the compactor will go on top of that, and the compactor may crush it a little bit. So what you are doing by doing this, the way the TCLP is done, the TCLP was not, when the TCLP was designed in late 70s and early 80s, there was no e-waste. So they never thought about that there will be a situation like this where people will have difficulty in even getting 100 gram of representative sample. It was mostly talking about regular industrial waste, which is a pile of waste which there you take multiple samples and try to do like a sample mean, population mean, uncertainty principle. We already talked about that in the class in the previous videos. So they never thought about this TCL, that there will be electronics which will have different components, all will be together. So that's where it's so variety of components. Some is plastic, some is glass, some is metal, some is different type of material there. So they never thought about that, and the whole thing together will become one waste stream, which is electronic waste. So in that event, some thought process is that let's leach the whole thing. Let's take the entire device and put it in a drum, and then we'll rotate the drum at that typical rotation. But since you have a bigger drum, it's difficult to rotate at the regular speed of what is required for TCLP. So some way what was done is we took we designed this large extractor. This was work done when I was in the US, so we did it over there. So we took, so here the principle is you take the device, you disassemble, you just unscrew, and you put the entire thing. So you disassemble it, and then you put the entire thing into this drum, where you have this TCLP fluid is already there. So whatever is the weight of this stuff, then you multiply it by 20 to get the 1:20 liquid to solid ratio, and that's the volume of liquid which is present over there. Then you put the entire thing and let it rotate. So that's the basic philosophy behind this. So here we had a large extractor, which is a 55-gallon drum, and we put it in there. Then we had the rotation. In terms of the rotation, it was half of the TCLP, the standard TCLP rotation, because that big drum, it was difficult to rotate at 32 RPM, so it was at 16 RPM. So the testing was done to compare how the big compares with the small in terms of, how RPM speed has an impact. So those testings are also done. It has already been published. It's there in the literature. Those of you who are interested to do research in this area, we can talk about that offline. Like you can send me an email, or you can look at those papers first, and then we can talk about those later. But in the case here, since in the big drum it was difficult to do 32 RPM, it was reduced to 16 RPM. It was found that it was okay to do that. So you can just take my word on it. So it was disassembled. And this is Mr. Kevin Van. This was his master's thesis actually. So he did his master's thesis on this particular project. So it was disassembled, and then we put it in those drum rotators, where you can see the disassembled portion is being put down there. The TCLP fluid is being poured. So you have disassembled things are going in, and so this is you see things in the TCLP fluid with disassembled computer, and things, printed wire board, and the things being put in, and then water was also put in there. So with that stuff, and then it was done on several devices. It was done on cathode ray tubes, it was done on computer CPUs, color TVs, color monitors, cell phones, keyboard, laptop, remote control, VCR. At that particular time, whatever was there in terms of the e-waste stream, whatever the different things present there, it was done on all those stuff, including the cellular phones. So what was found? It was found that every device had at least one model that failed TCLP for lead. So when we say fail TCLP, what do we mean? We mean that the concentration of lead in the fluid, in the liquid, that after rotation we take the liquid sample, so we filter it through 0.45, 0.7 micron, and then take the liquid sample and then digest that sample and test it on ICP or AA, as I have explained to you in the previous videos. If you have forgotten, go back and watch that video again. But and then we tested for lead, and we found that lead concentration was greater than 5 milligrams per liter. So this lead was more than 5 milligrams per, lead was greater than 5 milligrams per liter. So that actually means that it has failed TCLP for lead. So that's what it means. And for most devices, over 50% of the models failed. So for every device, at least one model failed. For most devices, over 50% of the model failed, again for lead. So as I said earlier as well, lead is the one which gets most of the attention in terms of e-waste disposal. And there were presence of other component has an impact on lead leachability. So there was some chemistry going on there as well. So those of you who love chemistry, there is some interesting stuff goes on in e-waste when you look at the e-waste leaching. There is a lot of chemistry goes between the iron and the lead. So higher the iron present, when we have more and more iron present, the lead leachability is less. As we are going to have less iron in the product, so that's what I was trying to tell that last year. We had a e-waste conference in XLRI Jamshedpur. I don't know if some of you were there, but in that conference I was discussing this. These are some of the research work that I was involved with. So I was discussing some of this work where I said that as we are going to this newer and newer electronics, as newer and newer electronics means less less iron and more plastics. So within the presence of less iron, lead leachability is more. So percentage wise, lead leach is more in terms of when we have less iron present. So there were some certain journalists were present, and they in the next day in the Hindi newspaper they had it some news there which did not really make 100% sense to me. Technically it was not correct, and it was not 100% wrong either, but they did not get it properly. And when you are trying to explain like a technical term in a very simple way in a newspaper, things does go wrong, and that was a very good example of thing went wrong. They did not even talk to me. They were just sitting in the audience in the back, and they wrote something, and then it would next day kind of had a heading in I think Dainik Bhaskar or Prabhat Khabar or some newspaper, I don't remember. It came in several newspapers in Jamshedpur. It was in XLRI Jamshedpur, and then they had the heading with a dash and my name next to it, as if I'm saying it, but I didn't say that. So I said something else, but they thought I was saying something else. So those things happen. So whenever you talk to media, be careful, and we all know that. So the presence of other components also has a lead leachability. More iron present, lead leach come into the water, lead leach come into the liquid form. And since this newer and newer electronics, the percentage of iron present is going down, percentage of plastics is going up. So even with the same amount of lead, even with the same amount of lead present in the newer models, you see them the lead leachability to be higher because the percentage of iron has gone down, and that we have seen in many of the experiments that we have done associated with e-waste. So lead leachability increases in the presence of in the absence of iron, rather not presence of iron, in the absence of iron. Here is some like a literature review kind of different types of lead leachability that has been shown. This is a log scale, and here these are the different types of electronics which is out there. We have different types of electronic items: desktop computers, keyboards, computer mouse, smoke detectors, color TVs, monochrome TV, color CRT monitor, flat panel, laptop, printer, VCR, cell phone, printed wireboard, all these different types of electronics or e-waste items, and this is in log scale. So be careful here, this is in log scale, lead concentration in milligrams per liter, but expressed in log scale. And the plot that you see here is actually we are showing the ranges. So since the concentration does vary over a several order of magnitude, so that's why it has been shown in a log scale. The y-axis is in log scale, and the middle dotted line is your TCLP limit. That's the TC limit. That's the TC limit for lead, which is 5 milligrams per liter. So that's what you see over there. So that's the, and as you can see, for most of these desktop computers, keyboards, computer mouse, smoke detectors, you see that for most of these things are above, for actually if you look at this dotted line, and then you see that for each one of these we have things above. We have things above we have things showing up above the TC limit for lead. So it's lead does leach out in a TCLP test, even with little bit of lead present in the solid phase. The reason for that, again, if you, those of you who love chemistry, reason for that, if you remember what is TCLP solution that we use, it is, it was a mixture of sodium hydroxide and acetic acid. Why we used acetic acid? Again, if you remember from the previous class, if you don't remember, I would kind of feel a little bit sad, but I don't, but because I have said that so much time during that particular video. Acetic acid is the final acid in a, whenever we have this food, what we are trying to simulate in TCLP test is it's a worst case leaching scenario in a municipal solid waste landfill. Municipal solid waste, because of the food waste and other organics, it decomposes, and finally you have the acetic acid being formed. So this acetic acid, which is that's why we use acetic acid in a TCLP test, because we are trying to simulate the worst case leaching scenario in an acidic condition of municipal solid waste landfill. We add sodium hydroxide to make it a buffered solution, because landfill systems are highly buffered system. So we make a buffered solution of 4.93 pH and plus minus 0.05, because you cannot have exact of 4.93. So pH is 4.93 plus minus 0.05. You have acetic acid and sodium hydroxide. So when you have acetic acid and sodium hydroxide in the TCLP fluid, you put some electronic waste in there. Electronic waste has lead, acetate, which will be there in the solution, and lead. They basically, you can think of, if in a simple way, if I can say, lead and acetate, they basically love each other, and they make a soluble complex of lead acetate. So this lead acetate soluble complex, it's a soluble complex. It's not, it will not say soluble, so it will of course not precipitate. It will be in the solid liquid phase. So that's why you will start seeing a lot of lead. When you have iron present, there is some competition goes between iron and lead, so that much lead does not come out. That's where we talked about in your high school chemistry, you had this competition between different elements in some sort of reaction. So that's what's happening there. But lead and acetate, they basically like to be together, and they produce a soluble complex, not an insoluble complex. It's a soluble complex. So impact of ferrous, that's what I would say. If the ferrous is present, if you have increased the ferrous concentration, as you can see over here, the y-axis is not in your it's a normal, it's not in log scale. Again, expressed in milligrams per liter. So lead in milligrams per liter, as you can see, if there is no iron present, we get to almost close to 45. But when it 20% of iron, it comes down to something between 5 and 10, 40%, even lower. If you have 68.2% of iron present, that goes very close to zero. So again, so as more and more iron is present, less and less lead leach out, with 15.8 grams of printed wire board in all the cases. So amount of lead was same in all these cases. Amount of iron keeps on changing. So we kept the amount of lead similar in all these 4 cases, but we changed the amount of iron present from 0% to 68.2%, and as you can see, there is a drastic impact of iron on lead leachability. That's again, those of you who are chemistry experts, you can probably explain it better than me, but that's what I already told you. There is some sort of competition going on. Those who are not chemistry expert, don't worry too much. We are not going to go into detail of this chemistry here. We are just trying to show you that it does have an impact, and of course, the chemistry experts can help us to understand it much better. You can use the discussion board and put some of your thoughts why it is happening. So, implication of steel, we see the devices with larger amount of steel, they tend to fail TCLP less often because the lead does not leach out, because it is the lead which is causing the TCLP in TCLP test for it to like fail. And size reduction has the opposite effect of what was expected. When we thought that if you do the size reduction, we will have more lead coming out. Actually, when you do the size reduction, you are doing size reduction from iron as well. You are doing the size reduction of ferrous as well. So, ferrous also has a bigger surface area now. So, it's a the impact, actually we saw that as we do the size reduction, there was more impact on less lead leachability. So, that was seen as well. So, when will this electronics will fail TCLP? What we saw that devices with lead containing printed wire board with less steel, they tend to leach lead more than devices with more steel. So, this is what I was trying to say, and that was I was quoted out of context in those newspapers that I just mentioned to you after a conference in XLRI Jamshedpur last year. So, but examples of devices with less steels are cell phones, as you know, we all carry the cell phones, remote controls, laptop computers. So, these things, and we are using more and more of these. So, these actually tend to fail TCLP more, although they may have the same amount of lead. So, again, this is the drawback of the TCLP test, because although the TCLP test is supposed to tell us whether it's what is the impact, but with the same amount of lead, since the less plastic is present, less iron is present, it is giving us higher concentration of lead coming out. But when it goes to a landfill environment, we are doing a lab test. When it goes to the landfill environment, there will be iron around it, there will be other things going around. So, it may not leach that much, which you will see in a little while when we discuss that further. So, that does kind of happen. So, even electrical toys, which is leaded printed wire board, little steel, all these electrical toys, electronic toys which makes little bit of noise, those will make some music and other stuff, has a small tiny printed wire board. If you even like a talking Barbie or any of these toys, you take it out, you will find that they have a tiny printed wire board, and they don't have any steel because it's all called clothes and plastics and other stuff. So, since there is no steel, there is no competition, whatever lead is there, it comes out in solution and it becomes a hazardous waste. Can you imagine that? So, even the talking, say when you are at a railway station or an airport, you see a small baby walking with that lightning in their shoes, or having that like little bit of musical kind of things coming out from their shoes. And that also, if you do a TCLP test on that, that also becomes a hazardous waste. So, so TCLP test, like it kind of becomes a little bit of ridiculous in this kind of scenario, but it's a test, and based on conditions, it does give a result. So, that's why any tool is out there. We as a human being, we have to make our decision whether how to take the data, how to make use of that data. So, you have this, we did some some of these toys, we did some TCLP test on them. So, we size reduced, we just put it whole thing in there and then rotated them through, and as you can see, a little bit of printed wire board here, and that came out to be a hazardous waste. So, all these toys were, we had to take it apart to do the TCLP test, put it in there, and then rotated it, and we found that it was a hazardous, it came out to be a hazardous waste, which is again kind of talks about that we have to be careful in terms of how we interpret the information we get. So, I wanted to show you that sometimes even tests as good as TCLP test, which is used many places like globally, that test is used globally in terms of the waste management sector. When it comes to electronic waste, it over predicts. The reason for why it over predicts is, as far as I know, I'm not a chemistry expert, but as far as I know, based on what my understanding of the chemistry in terms of iron, lead, and acetic acid, acetate ion, lead acetate solution, which actually makes a soluble complex, and that leads to increased leachability of lead. And although you see a high lead leaching out, but it may not be as bad as it sounds from the result that we get from the TCLP test. So, we have to use our brain and make the decision on that. So, that's kind of in terms of characterization. Now, we'll start looking at the recycling part. So how do you recycle? Who pays for that? What happens to it? How it is get recycled? So we'll talk about those stuff. And here the concept of social responsibility and those things comes in picture. So in terms of once the e-waste is discarded by the generator, like me and you throw the e-waste, or the commercial area, industry, institutional, wherever, if the e-waste is discarded, it can either go to these three paths. It can go to landfill or waste to energy plant, it can go to landfill or waste to energy plant. It can go to a recycle system, or it can be returned to like the manufacturer. So these are the three paths it can go. So let's look at the middle path first, recycling, which is promoted a lot. Then we'll look at the other two as well, and then we will wrap up this concept with that. So in terms of recycle, once it's discarded, what are the generator options if they recycle? In terms of recycling, what are the options out there? The generators options, if they want to recycle, first of all, they can return it to the original equipment manufacturers or a retailer. There are even as per the extended producer responsibility, as per the e-waste management rules, which was from 2016. These manufacturers have to take your electronics back. Say you bought a laptop from a particular store. Later on, after 2 years, 3 years, the laptop has gone bad, you can give the laptop back to that people. Until now, we don't do it because that person is not going to give you any money back. It's basically he will take the laptop from you and send it to the registered recycler, and the recycling will done. He will also probably not make any money if he goes by the rule. But what is happening right now is we are giving it to some kabadiwalas and other people to get few hundred rupees or maybe 1,000 rupee, I don't know, and depending on the instrument, depending on how good your laptop is, how bad it is, how good or how bad it is, and then how much bargain you can do. And but then it mostly ends up in the informal sector, and that's we already talked about that. It mostly ends up in the informal sector, doesn't get managed properly. So in terms of human health and environmental impact. So as per the new rule, as per the extended producer responsibility, and whatever is the global practice nowadays, is to have some sort of mechanism where either most of the places outside India, the way they have done it, wherever they have done it, is they have tried to come up with a pool of money, getting the money from all these different companies, and to make a kind of e-waste stewardship program where there is a central location which is serving for all the different manufacturers, and you can take your e-waste and go and give it to them and they take it. Some of the smaller item you can even do a mail back program where you can send your phone back. For example, cell phone, many companies they can take your cell phone back and they will give you some store credit, some online credit. For example, I don't know whether it happens, but something like this can happen, that if you bought the phone from Amazon, for example, and then after 3 years you want to sell it back to Amazon, so you send it back to Amazon, Amazon gives you like a few, it's like an online credit, and then you can use it to buy another phone or something like that, another electronics, depends on how this business model will work. But in terms of that is one option. There are different ways of doing that option is going around the world, and in India also things are working in that line, but still it's a little bit of progress needs to be made. So, but in some other places, for example, here this example is from US, where Dell will pick the Dell products for free. So Dell will have certain locations where the Dell products can be dropped off for free. LG offers mail-in return for cell phones. Any make they will take it. LG offers a locator to find the facility where you can take your device and drop off as well. Municipal people also do take electronic waste. Best Buy, which is another, it's a chain of a store, like something similar to Reliance electronics store we have, and there could be other electronic stores here too. I'm not a shopping person, so I don't really know much. So it's in terms of, but in terms of Best Buy, as some of you may know, it's a big chain of electronics store in North America. Also, I saw it in New Zealand, and it might be, I think it's in Europe as well, I'm not sure. So, but in terms of this, they have the e-cycle program where any of their store, you can take 3 items per household. They are ready to take it, nearly everything. up to TVs and other stuff, monitors. They took a DVD, home car audio, desktop and laptop computers. If you want the hard drive removed, then you can get it removed if you want, because many people don't want the hard drive. They want the hard drive to be cleaned off. So they will take the hard drive off and they will clean it off for you, and then they dispose it, because you don't want any of your information. You may have your tax information, you may have some personal photographs of your family, of your kids, which you don't want people to have access to. And small electric fans, vacuums, and then they charge some televisions and monitors. They charge $10, but they also give you $10 Best Buy gift card, because just to handle that, and does not apply. So there is some other products which does not charge. So based on how they have arrangement with different companies. What they don't take is a computer hard drive, internal and external computer hard drive, console TVs, electronic containing refrigerants. So because this is a hazardous, lots of hazardous chemicals there. Appliances, they don't do it. You can use your haul away or pickup programs for this. These things can be done during the one which I showed you, where they have a designated e-waste collection event. Like I think in the collection chapter in the municipal solid waste, I showed some pictures of Best Buy parking lot, if you remember that. So, and this is from the Westbys website. And this is how you can see the recycling at Best Buy. There are different components. You put it in different stuff, and they basically gets recycled. They also have you can help us provide. You can donate your old cell phones, and then that's money generated from that goes in terms of Boys and Girls Clubs of America. So, and then this is your Office Depot. They also have certain stuff you can recycle. You can get a box, ask a store for a tech recycling box. You pay certain money for those boxes. Say you are paying money to recycle. And this is kind of little uncommon in Indian context, isn't it? When you say people, oh, I will give you my electronics and I have to pay for it. So we don't have that mindset. We think that we should make money for each and everything. As I said earlier, if you buy a laptop in Canada, you pay around $30 extra for a $1,000 laptop, and to pay for the disposal fee. Here, as also you can see, there are a small box, medium box, and large boxes. There is a charge. A small box $5, medium box $10, and large box is $15. Because always there will be some to run these kind of programs requires money, and if you want to do it in an environmentally safe and sound way, that requires a lot of investment. So money has to come from somewhere. We have a tendency to think that each and everything should make money for us, and it may make money for you in a way upfront, but when you look at the long-term environmental impact and long-term human health impact, it is causing, because of informal sector, no control, things going into the water, going into the air, going into the soil. So we are paying for it, not directly but indirectly, through our health budget, through our health fees to the doctors, fees to these big hospitals. So but you can as you can see, there are recycling. This kind of recyclings does happen. So, and then we'll stop here. So let's stop at this particular point, and then we'll talk about the municipal government collections, how they try to fund it. And then we'll talk about the landfill side, and I'll show you another research example of where we have tried to do a simulated landfill for electronic waste, and what are the results came out. And with that, with that and some other global issues, we'll close this in the next video. So with that, thank you very much for being with us so long, and it's really keep the discussion board active. We are almost towards the end of the course, but don't forget, still you have the exams. Those of you who have registered, there will be some problem videos after. This is the last but one video. After this, there will be another video of lecture, and then we will have couple of videos of the problem solving, where you will be able to look at how to do the problem solving. It will be helpful to all of you, especially for those who are registered for the exam. You should definitely go over that videos, and then we'll also have a video summarizing those two surveys that we have requested your help with. One was on municipal solid waste. We have got a very good response. If you have still not done it, go ahead and do it. and the other one is on eWaste, which is it's going on. Please do that. Please finish that survey as soon as possible, and then I will come back and do a summary. The problem videos will be done by the TAs, and then I'll come back and do the summary of those two survey videos. Will be really fun to look at what we really found in terms of how the waste is managed, municipal solid waste is managed in the country. And with more than 6,000 people in this course, it would be really nice if all of you can give us the data. It will be cool to see. We'll put it on an India map. We'll put all those graphical locations, like which location we got how much response. We'll of course not tell your name because we don't want it to get personally identified. That's not our. We just want to get the data from eastern region, southern region, western region, and how things are happening, and how the Swachh Bharat mission and other things are happening in the country. That would be really cool to look at. So with that, let's close this video, and I'll see you again in the next video. Thank you very much.